Yes, team. Can you see that you can see my screen? Confirm, please. My voice is audible, screen is visible. Thank you. Session 2. Git branches. How they work, what are Git branches? So agenda of the session is overview, merging branches. This is what we need to learn. So by the end of the session, definitely you will have good understanding, excellent understanding I must say, about branches in Git. Git stores data. This will in fact give you insight also what exactly data, how exactly the data is stored in Git and how the branches are managed. It's going to be an interesting session. Git stores data as a series of snapshots. When you make a commit, Git stores a commit object that contains a pointer to the snapshot of the content you staged. This object contains the author's name and email address. I'm talking about this object. Git stores a commit object. So this commit object contains author's name and email address, the message that you typed, and the pointers to the commit that directly came before this commit, that is its parents. So that means if you are doing initial commit, you will have 0 parents. One parent for normal commit and multiple parent for a commit that results from a merge of 2 or more branches. This is the definition of a commit. What exactly happens? The commit object to be precise. Let's assume that you have a directory containing 3 files and you stage them all and commit. What will happen? Staging computes a checksum for each one, stores that version of the file in the Git repository referred as blobs, binary large objects, and add that checksum to the staging area. Like when you say git add readme test.rb license, you are adding 3 files to the staging area and then you are committing it commit-m initial commit. So when you create the commit, Git checksums each subdirectory and stores them as a tree object in the Git repository. Git then create a commit object, what I was trying to explain in the previous slide, that is a metadata, the email address and all as you discussed, and a pointer to the root object tree, a root project tree, so that it can recreate that snapshot when needed. Which essentially means, if you are, I don't know whether you are able to read that behind the lines or not, which is not written, that it is not actually making copy of your data. It is not doing that. That is the reason Git repositories are not as much of space consumed as the total file size is. They are not your copy of your files. They are snapshots and they are metadata so that you can recreate the file when required. So what happens? Let's understand, let's get inside this storage. Your Git repository contains 5 objects, 3 blobs representing the content of one of the 3 files, each one of the 3 files. Then one tree that lists the content of the directory and specify which file name are stored as which blob. And one commit with a pointer to that root tree and all the commit metadata. So see, you see here 98CA1, the first one and second one, and you see here commit size, tree, author, committer, initial commit of my project. This is the message. This is the commit object. This is the pointer, and this is referring to all the the 3 binary large objects. Blob, the first one, testing library. This is the first file. This is second. This is third. The 3 files. So when you say git storage, if you make some changes and commit again, the next commit stores a pointer to the commit that came immediately before it. So this was a snapshot A, commit size, tree parent, author and commissioner. This is the initial commit. Then this is another bug fixes. This is another message. This is snapshot B and this is snapshot C. So this is pointing to the previous one, that is pointing to the first one. So whenever you make any commit, that will have pointer to the first previous commit, which means this is another commit after this is second message we are adding. So this is another commit and they have pointed to the previous commits. That's how we are able to recover the old commits when required. Code review basics. Create a new branch for review. To review and identify bugs, to identify and enhance design issues, or to share code with multiple reviewers, or to test and identify potential performance bottlenecks. This is what we need to do when we are creating a new code, when you're starting programming. Let's understand the definition with those basic details, basic understanding what happens exactly behind the branch, behind the scene. So let's define the branch. A branch is a copy of original product release code. That is original branch. In a branch, developers can add, modify, update, correct, and bug fix in any code of the branch. A branch enables users to work on different features and updates at any time without affecting the original source code. Changes to a branch does not affect the original source code and are safe to test and review. So that means you can still continue working in the original branch, you can create a new branch, and you can continue working in the old and new branch, and then decide, merge, resolve the conflict and merge the branches. By default, all Git repositories have one default branch, and that is master, the original code. As you start making commits, you are given a master branch that points to last commit you made. With every commit, a master branch pointer moves forward automatically. Let's understand how this works. Branches and merge request. New features and bug fixes. Here you made a branch, you created a new branch out of it. Complete code, merge request to target, review the code, code approved, and automate and merge it with the master branch, because this is your main branch, master branch. So this way you can create multiple branches. One branch is started here by one team of developers, another branch is started here with another team of developers, but then finally they are merged together, all branches merged with the master branch. After this, code review and code approved, and this is iteration, iterated, iterate, fix and review, iterate, fix and review. So git branch. Now we can say we started from here, snapshot A, that is, this is our first branch, initial commit. Then we created one commit, that is snapshot B. This commit points to the old branch, the first, not branch, old snapshot, old commit, the first commit. Then we created one more commit. Here we created one branch. See, this master actually is the master branch which is pointing to this head, which is your final commit. And now you are creating another branch. This is another branch. So this branch also pointing to the same head, same snapshot. Head means the current you are working with. That means if you want to work with this branch, you have to check out. So where the head is, that points to the branch where you are working. So the real pointer, real tracking is done by head and the branch identifier. So if you ask me, it works like this. Wherever the head is, that is your current active branch where you are working. And the master points to the last snapshot, last commit, where it is done. And then every commit has the pointer to the previous commit, and starting from all the way to the first commit. So this is how you create a new branch. So this is first commit, initial commit, second, third, and we create a new branch, and this is testing branch is created. Now this testing branch, where the head is, that will be your active branch. This is where you will be working. So how do you change the head? When you create a new branch, it creates a new pointer for you to move around, and that's how you create the branch. Get branch name. This create a new pointer to the same commit you are currently in, because they will point to the, obviously they will point to the same commit. Every commit is identified by this pointer, right? So this testing will also point to the same commit. But where are you working? You are still on the master. How do you start working on testing? That is where we call it as a special pointer head, as I was referring earlier. That point to the local branch you are currently in. So by default you are still into master branch. So initial commit, second commit, third commit, here you created a branch and the branch is testing, but you are still, your head is pointing to the master. That means you are still working in the master branch. So you are still on master branch, remember. The git branch command only create a new branch. It does not switch to that branch. You are still working in the same branch, master branch. So what branch you are currently in? How can we check that? That can be easily, you can easily check with git log command. Git log will tell you that when you say this option is called a decorate. Like for example, git log decorate, git log online decorate, and this will give you where you are. This is your commit, this is your head pointing to master. So you are working in master right now. And there is another branch called testing. So this with this head is master is also pointing to this, testing is also pointing to this, but you are on master. And these were old pointers. This is the second one and this is the first one, initial commit. So you can see the master and testing branches that are right there next to this commit. So this says clearly that head, our pointer, our identifier to identify which branch is the current branch, head is pointing to master. But there is another branch called testing, again both pointing to the same commit. So how do we switch branches? To switch an existing branch, you run the git checkout command. So let's switch to the new branch, and you do that by using git checkout testing. So the head pointer will start pointing to testing now. Now onward, this testing branch will take its own independent step, independent path, independent journey. So you start committing here, master will start pointing from, so from here onward, master will take its own journey, testing will take its own journey, both will start independently in their own way. Where are you working will be decided by head pointer. How do you decide where you are working? With git checkout. And this is where we are. Now switching branches, now we are good, we are moving ahead. What is the significance of that? Obviously the significance is master branch was left behind. Now you are working with testing. Master branch pointer is pointing to the old commit, third commit. But after that you made one more commit. That commit will point to the new commit, and that is your test branch. That is, you see that master is still pointing to this, testing is pointing to the new commit, because your pointer head, which is identifying your current branch, is pointing to testing. So this is the new, the master will not identify this new commit. Well, let's do another commit, that is the new test.rb. This is the next commit available here. Git commit message and made a change. Now switching the branches. This was your testing branch. You made a commit here. They are identified by testing branch. What if you have made another change? Now your testing branch has moved forward because of this commit. But your master branch is still point to the commit you made when you run git checkout to switch branches. Still, that is third commit. Now if you switch to this, switch to back to the master branch, make a commit here, git checkout master. So you are back to master. That you left separately. You are working on now master because your head is pointing to that. So what this checkout is doing? Checkout is ultimately pointing to, making this a special pointer head pointing to the current branch. That's the checkout word is doing. That command did two things. It moved the head pointer back to point to the master branch, and it reverted the files in your working directory back to the snapshot that master points to. That is what has happened. This also means that the changes you make from this point forward will diverse from the older version of the project. They will be different. Let's make a few changes and commit again. We make changes, test.rb, again make a commit, made some other changes. Now there are two different branches now. That is what I was referring to. This is a commit made here, because now the head is here. Now we made some changes. So this change is different, this change is different, this change is created in testing branch, this change is created in master branch. Still the path will follow the same, pointing to all old commits. Now your project history has diverged. You created and switched to a branch, did some work on it, and then switched back to your main branch and did some other work. Both of these changes are isolated in separate branches. That's what the point is, and that's what the benefit of Git actually is. This is the production level use case and requirement maintaining multiple versions of the files. Now you see this is a different version, same file updated here, same file updated here. This is a different version pointing to a different snapshot, this is pointing to a different snapshot. But up to here they are same. Up to here both are pointing to same. This one is same, this one is same, this one is same. But this change, here suppose one line is changed, here another two lines are changed, they are different. So you can switch back and forth between branches and merge them together when you are ready. And you did all that with simple branch checkout and commit command. That's simple, is it easy to work with. So you can also see this easily with git log command. When you run git log online decorate graph all, it will print out the history of commit showing where your branches pointers are and how your history has diverged. So this is what you will see, git log online decorate graph all, and you'll see this is a current head is pointing to this and master you are here, made other changes. This was old one testing, made a change, and both are pointing to this. You see here this is pointing to this, this is pointing to this, and this is our old one, and this is second one, this is this is third one, this is second one, this is first commit. So this is the branch here. From here onward you see one branch is this and second branch is this. These are two branches from this point. One is testing, one is master. Which one is current? Identify by head. Head will tell you which is the current. Because a branch in Git is actually a simple file that contains 40 characters, checksum, of the commit it points to, branches are cheap to create and destroy. They do not take much space. Creating a new branch is as quick as simple writing this 41 bytes to a file. That's it. So summary, what we have learned. Git uses branches heavily to switch between multiple tasks. To create a new local branch, we use git branch, name of the branch. To list all local branches, you can use git branch, and star will mark the current branch. To switch to a given local branch, you use git checkout branch name. To merge changes from a branch into local master, you use git checkout master and git merge branch name, the changes of which you want to merge into the current one. That's all for this session. Thank you very much.